Today we're going to work through how to add and subtract mixed numbers. Now when we add and subtract mixed numbers, we're doing basically the same steps that we did when we added and subtracted fractions, except in this case we have a whole number to deal with, whether it's addition and it comes out to an improper fraction and we have to convert it back, or if it's a mixed number that we have to borrow from in order to make things equivalent. So I'm going to go through 5 different examples following these steps. In step 1, we're going to write the problem down vertically, just like we did when we added and subtracted fractions. Step 2 is we're going to find the LCD, or the LCM, the lowest common multiple. Step 3, we're going to make the fractions equivalent. And then step 4 will be, I'm going to add or subtract. Now, if I'm subtracting, which we'll see in a couple of the examples, and I need to borrow, I borrow from the whole number, but I borrow the amount that makes it whole. So I need to look at the denominator from the fractions that I made equivalent and use that when I add it to the numerator. So let's go through some examples. And then lastly, the thing I want to do is always simplify or reduce my fractions. So my first example is 1 1/4 plus 2 2/5. I'm going to write it vertically. Now I'm asking myself, where's the first time that 4 and 5 are going to collide? Where are they going to meet? What's the lowest common multiple that they have in common? And when I look at these two numbers, I know that they're going to meet at 20. So I'm going to make a denominator of 20. Now I need to make them equivalent. How many 5s go into 20? 5 times 4 is 20. So 2 times 4 would be 8. 4 goes into 20 5 times. 5 times 1 is 5. Now my denominator always stays the same, so I bring it down. In this case I'm adding, so I'm going to take my 5 and add it with my 8 to make 13. And now I'm going to add my whole numbers of 1 and 2 to make it 3 and 13/20ths. In this example, 13/20ths is reduced as low as it can go because 13 is a prime number and it does not go evenly into 20. So I'm finished. In my second example, I have 3 2/3 plus 4 2/5. Now in this case, I'm looking for the first time that 5 and 3 are going to meet, and they're going to meet at 15. Now I need to make them equivalent. 5 goes into 15 3 times, so 3 times 2 is 6. 3 goes into 15 5 times, and 5 times 2 is 10. Denominator comes down. Now I add my numerators. 6 plus 10 is 16, and 7 plus 4 is 3 plus 4 is 7. Now, in this case, I have an improper fraction. I can't have a mixed number with an improper fraction. So what I need to do is I need to convert 16/15ths into a mixed number and add that whole number portion to the 7. So I'm going to go ahead and bring that 7 over because I know I'm going to need to use it. Now, I divide and I write it as I read it. 16 divided by 15. 15 goes into 16 one time with 1 left over. So 16/15ths is the same as 1 1/15. I take this one whole number and I add it to that 7. So that 7 becomes an 8. And I'm left with 1/15. So 8 and 1/15. 7 and 16/15ths is the same as 8 and 1/15. I've just renamed it to look like it's supposed to. Now I've got another example of an addition problem here. I'm going to do subtraction on this one. 7 1/2 minus 4 1/3. Now I'm looking for the first time that 3 and 2 are going to meet, and they're going to meet at 6. It's the lowest multiple that they have in common. 3 goes into 6 2 times. 2 times 1 is 2. 2 goes into 6 3 times. 3 times 1 is 3. Bring down my denominator. 3 minus 2 is 1. 7 minus 4 is 3. I cannot reduce 1/6 any more than it is, so I'm finished. Now I've got a tricky situation. I see a lot of errors from students with this particular problem because it's a whole number. And when I write it out, this is what it looks like. Now, students a lot of times will just try to bring this 7/8 down. And I try to talk to them about how you can't just bring it down when it's on the bottom. You have to have something to pull from it. In this case, the 6 is there. I'm gonna have to rename that 6. I'm gonna make it have the same value, but turn it into a whole number. So what I do is I look at the denominator, I know that that's 8. So when I convert 6, I'm gonna change it to 5 and 8/8. 5 and 8/8 is the same as 6 because 8/8 is equal to 1. Now, I've got my denominator is alike already. 8 minus 7 is 1, and 5 minus 2 is 3. So I had to rename the whole number on that one in order to make it work. Last example, I'm going to have to borrow in this one, so I'm going to show what techniques we need to use for that. 6 and 7/24 minus 5 and 1/3. Now I'm asking myself, where's the first time that 3 and 24 are going to meet? And their lowest common multiple is 24. So I'm going to push the 7/24 over, and I'm going to change the denominator with the 3 to 24 and make it equivalent. 3 times 8 is 24, so 8 times 1 is 8. Now, here's the tricky situation. I have 7 on top here, but I want to pull 8 away from it. Just like in normal standard algorithm subtraction, that doesn't work. It's going to be a negative number. So what I need to do is I need to go borrow from the whole number, which is 6, and I'm going to turn that into a 5. Now the amount that I borrowed was the whole number of the denominator. So I'm borrowing 24/24. And what I want to do is I want to add that to the numerator that's already there. I don't want to replace it, but I want to add it. So 24/24 gets added to the 7 because it's equal to the 1 we borrowed. And 24 plus 7 is 31. Now I can do my subtraction. 31 minus 8 is 23. And 5 minus 5 is 0. I cannot reduce this fraction anymore because 23 is a prime number and it does not go into 24 evenly. So, as a recap, I continue to preach to my students that lining things up vertically, staying organized, making sure you find that common denominator and make the fractions equivalent, and then most importantly, make sure that you deal properly with the sign that's there. If it's addition, make sure you're adding. If it's subtraction, make sure you're subtracting. And always at the end, simplify or reduce.